right, here we go. Lesson 46 is solving problems using scientific notation. What's our objective? Get ready?
Solving problems using scientific notation.
Very good. Today we're going to be multiplying scientific numbers and dividing numbers that are in scientific notation. Then, importantly, we're going to find out the right way to write it in proper scientific format. We're going to learn where to put the decimal so that it's in the proper place. So let's take these two, 1.2 times 10 to the 8th and 4 times 10 to the 6th. The rule is multiply like things first. So 1.2 and 4 are the coefficients, we multiply those. And then the exponents are like things, so we multiply those. So 1.2 times 4 is 4.8. Then the 10 to the 8th and 10 to the 6th get multiplied together because they're like. And the rule is, think of your law of exponents. If the bases are the same, we add the exponents. What do we do to the exponents? Get ready? Add. So you're at 4 to the 8th times 10 to the 14th. We're going to do several more like that. All right, we're going to do now 7.5 times 10 to the 4th times 2 times 10 to the 3rd, and there's going to be a rule here about the digit to the left of the decimal, so we're going to get to that. Gage. Not right now, just wait. Joseph.
Couldn't you technically just do it like 7.5 times 10 to the 4th and then do 2 times 10 to the 3rd?
How would you multiply it though? So so we're going to do is regular multiplication, but the way we do it is by taking the coefficients and multiplying those. 7.5 times 2, just double that, that's 15. And then do the exponent part, 10 to the 4th times 10 to the 3rd. Remember, we add the exponents. 4 plus 3 is, get ready? 7. Now, this is the big hint I left for this one. Leave one digit to the left of the decimal. Well, the decimal right here, it's invisible, but it's there. There's 2 digits to the left right now. Well, that's not in proper format. The proper format is 1 digit to the left of the decimal. How many digits to the left? Get ready? 1. So I have to move it until there's only 1 digit. So I move it right here. Now there's 1 digit. It has to be a non-zero digit. Now there's a 1 right there. Well, wait a minute. Can I just, like, if I feel like it, change a number? I just changed inequality. I just made this one smaller, but I can keep it balanced. If I make this one smaller, can I make this one bigger and keep a balance? So from a 15, if I made it into a 1.5, I made it 10 times smaller, so I can make this one 10 times bigger by changing the exponent by 1. So my final answer would be 1.5 times 10 to the 8th. And we're going to do that several more times. We're going to be moving the decimal the right direction and then changing the exponent, so that there's 1 digit to the left of the decimal. How many digits to the left of the decimal? Get ready?
1.
1 digit. So, let's try this one. 4.0 times 10 to the 4th times 5.0 times 10 to the 5th. Let's take the 4 times the 5, which is, get ready? 20, good. And then 10 to the 4th times 10 to the 5th. 10 to the 4th times 10 to the 5th is, get ready?
10 to the 9.
Oh, you guys are awesome. Thank you. Is this is my question, is it in proper scientific format? Nod your head yes or no. No, what's wrong with it, Kaylee? Yeah, there's 2 digits. That's wrong. So I have to move the decimal so that there's 1 digit to the left of the decimal. What direction of the decimal? Get ready?
Left.
Left. So I'm going to move that 1 time so that I have, instead of a 20, I went down to a 2. I made it smaller by a factor of 10. So I had to make this one bigger by a factor of 10. I'm going to change that to Ethan.
I had a question about the thing. If on a little bit earlier in the slide it said it had to be a non-zero.
It has to be non-zero, meaning if it's 0.3, that doesn't count.
Oh, okay. I thought it was if it was like 50.
Oh.
Have to divide it twice and make it 0.2 times 10 to the 11.
That's a good question. No, it's just this one. Yeah. Okay. Ethan, by the way, what would this become, the 9?
It becomes 10.
A 10, very good. So my final answer is 2.0 times 10 to the 10th. Do I have to write the 0.0? No, I can leave it 2. Okay. Okay, next, division. It follows the same idea. You divide the similar things. So the coefficients that are being divided, just divide those separate. 4.8 divided by 4. Just to save time, I'm going to tell you it's 1.2. And then these are going to divide by the rule. The law of the exponent says if the bases are the same and you're dividing, the powers subtract. 6 minus 3 gives us, I'm going to put a little box and do a minus sign. 6 minus 3 is 3, so it's 10 to the 3rd power. I ask, is it in proper scientific format? Nod with your head, yes or no? Yes, there is one non-zero digit to the left of the decimal. Connor?
This is Boone.
Yes?
Avery Lawton is checking out.
Okay. Connor, what's your question?
What happens if it's like 3 digits?
Ooh, okay. So let's say I had 289.3 times 10 to the 4th power. And it's not in proper scientific format, is it? I'd have to move it 2 times, once, twice. I made it from a really big number to a smaller number, so I made this smaller. I need to make this one bigger. If I went 2 times, guess what I'm going to do to the exponent?
2 times.
I'm going to make it 2 places bigger, or a 6. Great question, Connor. Because I don't know, I think I have one example like that in here, but I wanted another one. All right, let's divide. 1 divided by 4 is equal to 0.25 times, subtract the exponents. 8 minus 3 is, get ready?
5.
10 to the 5th. It's not in proper scientific format. I need a digit on the left side, so I'm going to have to move the decimal the other way. How would I do that, Samantha?
You would go to the manager, you would do right sometime, and then you would do top one from the, and would make it under.
So wait, you're saying, so I went from a really tiny 0.2, now it turned into 2.5. I got bigger. So I have to make this one smaller. If it helps, I like to write it when I teach it to write bigger and smaller because it helps you go, oh yeah, I gotta keep it balanced. If I take 1 away, I gotta keep it balanced by adding 1 over here. Gage.
So it's an inverse relationship.
Yeah, I would think of it like an inverse. Okay, great comment. All right, it's proper scientific notation. Okay, your turn. Would you divide 1.44 times 10 to the 12th divided by 1.2 times 10 to the 8th? Put your pencil up when you've got it. Okay, Joseph.
One, like, do you want me to go through the whole thing?
Oh yeah, what was your division right here?
So it's, 12 goes into 14 once.
You just tell me your answer.
Okay, 1.2,
Okay, and what was your 10 to the
4th.
4th? Is it in proper scientific notation?
Yes.
Yeah, we didn't have to move this one. It was the easy one, right? 1.2 times 10 to the 4th. So if anyone was not sure on that decimal part, when you're dividing with decimals, move that over once. You got to move this one over once. I think it was one like on the test like that. And then get rid of it so you don't have to look at it and it doesn't mess up everything. And then move that ahead. So 12, as Joseph was saying, would go in once. Okay, good. How about this one? 3 divided by 4 and 10 to the 8th divided by 10 to the 4th. 3/4 times 10 to the, what do I do with my exponent there? 8 and 4. What does my exponent become? Bo.
The exponent becomes 4.
Very good. 10 to the 4th. And then 3/4. Let's get a decimal for that. Let's call that point, I think 3/4. 0.75. Okay, how would I adjust the decimal here? Madison.
So you move it to the right once, and then you take 1 away from the 10, and so you have 10 to, so 7.5 times 10 to the 5th.
Awesome. We made this one from a 0.75 into a 7.5. It was 10 times bigger. We make that 10 times smaller. 7.5 times 10 to the 3rd. Give me a thumbs up if you're like, I feel pretty confident. I think I can move the decimal, multiply, and divide, and give it to me in proper format. Who can tell me in their own words, what is proper format? Tell me in your own words. Lexi.
It's making sure that there's one number to the left of the decimal
Okay.
and making sure that it's balanced.
Oh, good, balancing the exponent, if you did make that move, that you balance the exponent, perfect. All right, so we're gonna go, oh, there's one last piece of scientific trivia. 300,000 kilometers per second, that's the speed of light. So 300,000, would you please convert that into scientific notation for me? Put your pencil up when you've got it. How would I write that in scientific notation? You need that for the practice set, problem E. All right, gauge, what is it?
3.0 times 10 to the 4th.
Super close, hold on.
Bed.
There it is, bed. Right there. Okay, use this for problem E. Your practice set, you're gonna do A, C, woo, D. Hold on a second. Let me read those.